So, oh, you just get ready. Okay. We, in chapter 3 and 4, started dealing with how to solve polynomials. Mainly quadratics. Chase, focus up here. Mainly quadratics. And then we got to chapter 4 and we started graphing these things. We wanted to graph them because we wanted you to see them. We wanted you to have like a box problem where it's like, okay, so there's a maximization problem. There's something going on. Like that's what we use these things for. But now that we've looked at them, we've seen what they look like. Now we tuck the graphs away. Now we look at them algebraically. So we're going to actually take this thing, and before we gave you factored form, and then we told you to graph it. Now you're going to go backwards. You're going to look at the graph, and you're going to put it in factored form. So before we do that, tell me this. What's the x-intercept that I get from this? Yeah, negative 11, 0. You're really good at that. That's why I started with that. Because now, when I look at this, what factor relates to negative 1? X plus 1. Okay, that would be my factor. What factor relates to 3, 0? X minus 3. And what factor relates to the last one, just x minus 5? Those are my factors. Notice, up here, it says assume a is 1. Now, when we did quadratics in chapter 3, we would give you the start of a quadratic and you had to find a. That gets a lot more complicated when you get degree 3, degree 4, degree 5. So we actually let you assume it's 1, which is really nice, because now factored form is this. F of x equals x plus 1 times x minus 3 times x minus 5. Done. That was pretty easy. Not too bad. Aiden's sitting over there like, Nichols, this is going to be the easiest chapter ever. No, he's not. Because now we got to change it to standard form. So, you distribute. So distribute the first two things. There's no pairs, there's no nothing nice looking, so we just got to do it. So go ahead, you distribute x plus 1 times x minus 3. I'm also going to do it. We're going to compare. So you should have that. What's up there? But then, now all of you get so tempted to do this. You're just kind of like twitching to do it. You're like, Nichols, I want to start multiplying. Don't do that. Combine your like terms first. So, I combine my like terms, and I get x squared minus 2x minus 3, and then I get x minus 5 on the tail end. Now we distribute one more time. However, what I like to do is if I have a smaller piece, so this is, the first part is a trinomial because it has 3 terms. The next part is a binomial because it has 2 terms. I actually like looking at my binomial and multiplying from that in. You don't have to do it that way, okay? That's just the way I like to do it. So I'm going to do it that way. So I'm going to take x times x squared. What's that? X cubed is good. X times negative 2x, I get negative 2x squared. And then I go x times negative 3, so I get negative 3x. I'm going to change colors. You don't have to. So now I go with the negative 5. Multiply there. And so I got that. Is that done? No, we gotta combine our like terms. Now it says standard form. Standard form means that you need your highest degree to the next highest degree, to the next highest, to the next, and so on and so forth. So if I start at 3, then I have to have 2, then 1, then 0. So I'm gonna write this out. My highest degree is x cubed. I actually cross it off then. Then I look for my squares. I got negative 2x squared and negative 5x squared, giving me 7, negative 7x squared. Negative 3x and positive 10x gives me 7x. And then I just got 15 at the end. That right there, folks, is standard form. So that's the standard form of a cubic. That function. Questions? Okay, we're actually not going to do 2. However, I would recommend that you start at 2. So I'd cross the graph off for 2 and point an arrow going down to 3. But then I would actually use 2 as your starting point because this takes up some space. So, number 3. Now remember, I'm looking at my dots, my x-intercepts. I am not looking at y. I could care less about the y's. I am only looking at my x-intercepts. So, what's my first x-intercept? No. It is x plus 3. Well, it is x plus 3, but it's not just x plus 3. What's happening?
3 squared.
It's squared because it's a bounce. That's right. Oh, so we got a bounce. What about 0, 0? What's that? Just x. What about that one? Boom. X minus 4 squared. So I'm going to write them together. Now, you can go left to right. That's always a good thing to do. But I will be honest, I normally just put the x in the front. Okay? So I'm going to write this. Say f of x equals x times x plus 3 squared times x minus 4 squared. What degree is this? 5. Oh, here we go. So this is factored form. First step to change forms, expand. So instead of writing the squares, I just get rid of the squares and I start writing the whole thing out. So I got x. I write x plus 3 twice. And x minus 4 twice. Now, actually, I take that little x by itself and actually like tuck it in my back pocket because it's the easiest thing to distribute. So I'm going to deal with it like towards the end, not the very last, but towards the end. And so I break it up like this. Honestly, the first thing I look for is I look for conjugates again. So I look, do I have an x minus 4 and an x plus 4? Do I have an x plus 3 and an x minus 3? And I don't. That's the best thing you can have. The next best thing that you can have is the same exact thing. So x plus 3 and x plus 3, it's actually not that bad. So I want you to distribute this out. And then I also want you to distribute x minus 4 times x minus 4. So get those two things, and then we're going to fill it in. I'll walk around and check and see how we're doing. And then we really start the fun. And if you notice a pattern, use the pattern. All right. So what do we get? We get, what do we get in here? X squared, then what?
Plus 6x plus 9.
That's good. What about the next one?
X squared minus 8x plus 16.
Good. So you're just distributing that out. Okay? So you do that for both of them. All right. Now you have options. It is plus 16. My bad. Good catch, Chase.
Yo, Chase, did I say plus or minus?
You probably said plus. I just wrote the minus. All right. So now this is where I'm going to just take this x and put it into my first thing in parentheses. So this gives me f of x equals x cubed plus 6x squared plus 9x, and then I just leave the other piece. So this x does not multiply all the way through. When you're multiplying pieces together, you don't take it and go through every single thing out there. You only multiply to the thing next to it, or if you choose to jump over something, you only get to multiply to one thing. So please don't make that mistake. But now we have this beast. When I multiply these two things together, how many items am I going to get? I'm going to get 9. Because I take this 3 and I multiply it by these 3 items. So there's 3 terms. Then I take the middle one, I multiply it by those 3 things. I get another 3 terms. And then I take the last and I multiply it by the 3. So I have 3, 3, and 3, so I get 9 terms. And then we combine. So we're going to start this out. So I got f of x. And I'm going to go x cubed times x squared. What's that? X what?
X5.
Yeah, x to the 5th. I go to the next. So first times the middle. Negative 8x. What power? 4th. And then I go first times the last. So this is the easiest. So plus 16x cubed. And now I start it over. And so now I start 6x squared times x squared gives me what? 6x to the 4th. What's the next term? Negative
48x squared.
Good. No. Negative 48x cubed. And then our last one, 6x squared times 16. 96 x squared. And then we have our last. So first one, really quick, 9x cubed. What's my next one? Just make it negative. What's my last one? Nope. 144. 144x. Is that in standard form? Not yet. X to the 5th, biggest power. Crossing it off, writing it down. My next biggest power is x to the 4th. I have 1x to the 4th, I have 2x to the 4th, that's it. What do I get when I add those up? Negative 2x to the 4th. Is negative 8, positive 6. All right, then I'm looking at my cubes. I got 16x cubed, negative 48x cubed, and I got a 9x cubed. What's that add up to? Negative 32 I got as an answer. I heard a negative 33. I got a weird look. What are you thinking? No. What is it? Negative 23. X cubed. Cross off the cubes. I have 96x squared minus 72x squared, giving me 24x squared. And then I'm left with plus 144x. Nice. Questions?
What is the point of numbers?
So, there is a question like, why would I change forms? Why would I ever go from factored form to standard form? To be honest, you might not necessarily do that. However, we need to have an understanding from going to factored, from factored to standard, because eventually you're going to go from standard to factored. So we're going forwards. A couple days, we're going to put the car in reverse and start going back. So, any questions on this? Ooh, you're jumping way far ahead. All right, we're going to actually go past 4. We're going to just talk about 5. So, here's the thing about 5. Let's take a look at 5. What's my factor right here? Yeah, so x plus 1. So my factored form would be something like f of x equals x plus 1. What's my other factors? I don't and I do. How many times do I cross the x-axis? Once. I have 2 curves. What is this? What degree would it be? 3. So if it's degree 3, it has 3 solutions. I have 1 solution. What are my other 2 solutions? Zach, do you know? All right, never mind. What's my other 2 solutions? What kind of numbers are they? Imaginary. So that means it's f of x equals x plus 1 times something. Now today, I'm writing something. Tomorrow, on Monday I should say, we're going to figure out what that something is. Now, let's think about that. Let's say this is my function. So I could actually say that x plus 1 times something equals x cubed plus 3x squared plus 7x plus 5. How can I figure out what that something is? How would I break these 2 things up? They're multiplied, so I could actually divide, which means I can divide that. We're going to be dividing polynomials. Ooh. So we're going to review something really quick. 210, give me a number. There's the door. No. What?
31.
31. Choose a better number. Choose a small number.
9.
9. All right. All right. Chase, move up here. Don't sit by each other next week. No, I'm serious. Move. All right. So, we got 210 right there. How do I do long division? How many times does 9 go into 2? 0. Doesn't. How many times does 9 go into 21? 2. So I put a 2 over the 1 because I had to go to 21. So 2 times 9 is 18. Does that give me 39? Or what happens? What do I do now? We subtract. So I minus, even though that's positive, right? We're going to use that later on. So I subtract and I get 3. What do I do with that 0? Drop it down. How many times does 9 go into 30? 3. Okay. A couple ways you can write this. So you can write it as 23 remainder of 3. You can write it as 23 and 1/3, right? Which is where we would really be doing this. We'd be really writing our remainder over that 9, and then I just reduced it. But what that's telling me is 9 is not a factor of 210. Okay? Now we're going to do something else. Now I'm going to take 210, but this time I'm going to divide it by 5. Actually, I lied. We're going to divide it by 2. So if I divide this by 2, how many times does 2 go into 2? 1. All right. So I put a 1 up here. I put a 2 here. Just like we did in the last one, I always subtract. So I minus, and I get 0. And then I drop down the 1, and I get a 1. How many times does 2 go into 1? 0. It doesn't. So I put a 0 up above it. 0 times 2 is 0. I mean, if you want to subtract, you can, but you just get 1. I drop that 0 all the way down and get a 10 there. 2 times what is 10? 5. So I put a 5 up here. Go 5 times 2, I get 10. I subtract, I get 0. If I have a remainder of 0, it means that these two things are factors. So now I can say 2 times 105 equals 210. So, on Monday, we do long division with polynomials. We will take something like this. And divide it. And we will find the other factor. All right. That's your lesson.